Okay, so we're back now in Unit 1, Lesson 2, and we're looking at domain and range using interval notation. And remember that we just learned about interval notation in our first lesson, so you can go back and review those videos if you need some help with interval notation as you're working through these examples. So on the front of the foldable notes booklet, if that's how you're taking your notes, you'll notice a place to record the meanings for these four terms: domain, range, relation, and function. And you learned these in Algebra 1 and Algebra 2, so we're not going to dwell on them too long. The domain is your x values, the range is the y values. When you're looking at a graph to determine the domain and range in interval notation, it's always a good trick for the domain to read that graph from left to right, because your interval has to go in order from least to greatest, and so you look for the smallest x value and then the highest x value for your domain. For the range, since that's y values, you read your graph from bottom to top, because your smallest y values occur at the bottom and the highest at the top. Okay, a relation is a set of ordered pairs, x comma y, or an equation in two variables, x and y. And then a function is a relation where each x value pairs with exactly one and only one y value, right? Each x has its own unique y. That's when a relation is also a function. And if you're looking at a graph, hopefully you remember from Algebra 2 that that graph must pass the vertical line test to be considered a function. Okay, so in example 1, these are bounded relations and functions. And we talked about bounded in our notes in the last lesson. So hopefully you recall that bounded means that you've got two endpoints in your interval. Okay. A few new words that we're going to look at here real quick. An open interval occurs when both ends are non-inclusive. We'd have parentheses on both ends. A closed interval occurs when both ends are inclusive, so we'd use brackets in that situation. Half-open intervals have one end open and the other closed, so we'd have one parentheses and a bracket in that interval situation. So in example 1, here we're looking at an oval or an ellipse, is what we like to call those in conic sections. And to find the domain, we look for the x values. And when I look at this graph, I have my smallest x value here at -1. And then I look across, because I read from left to right for domain. And then there's my largest x value here at 3. So my domain, I can see it's continuous all the way here from -1 over to 3. So could x be 0? Yes, right here it would be 0. Could x be 1 2/3? Yes, right here. It could be any value between -1 and 3. Could x equal 4? No, because that's outside of the domain. It's not visible on the graph. So our domain, we don't have any open circles on this graph, so we assume that it's closed, and it's going to be closed from -1 to +3. And so we use brackets to indicate that that's a closed interval. Okay, now the range is bottom to top, right? Because we're going in order from least to greatest. So our smallest y value is down here where y is -2. And then we keep going. It's continuous all the way up here until the highest y value, which is at +4. Okay, those are closed circles, so this is going to be a closed interval. So we'll use brackets with our lowest y value of -2 and our highest y value of +4. Okay, then we want to decide, is this a function? And we can use the vertical line test to make that determination. So if I go ahead and make a vertical line here through my graph, I can see that this graph this vertical line hits or intersects the graph in two places. That fails the vertical line test, and so no, this is not a function. Remember, to be a function, each x has to have one and only one y paired with it. And at this place at 2.5, I can see that I'd have two different x's, a positive x, or sorry, two different y's for that x of 2.5. I'd have a positive y value and a negative y value paired with it. And so that fails the vertical line test, and it's not a function. Okay, so go ahead and pause the video and then come back after you've given number 2 a try, and we'll go over the answers together. Okay, so we're back. I wanted you to give number 2 a try, so we're going to go over this together. The domain, we want the x values represented on this graph in order from least to greatest. So I'm starting here at my lowest x value, which is -2, and that's a closed circle, so we'll use a bracket on -2. And then I follow, and it's continuous all the way until my highest x value, which is at 2, so +2. However, that endpoint is an open circle, and that means it's non-inclusive, so I use a parentheses. So my domain is all these x's from -2 inclusive all the way up to, but not including +2, right, because of that open circle. So 1.99999 would be fine, but it can't actually equal 2. And then the range, we're going to look at y values now from least to greatest. So we start down at the lowest bound of our graph, which has a y value of -2 and a closed circle. Then I look all the way up to the highest possible y value, which is up here at +4. And so I can write my range, since these are both closed, as the interval -2, which is inclusive, up to and including the 4. So I have brackets on both sides of that interval. Okay, and when I look to see does it pass the vertical line test, everywhere I would draw a vertical line, it would only intersect in one place. And so yes, this is a function. Okay, so go ahead and try example 3 now on your own, and we'll come back after you pause the video and try it, and we'll go over those answers. Okay, so we're back, and I asked you to try example 3, so now let's go ahead and go over that. For the domain, our lower bound of -2 has an open circle, so we're going to use a parentheses on -2, then it's continuous all the way through to its highest x value here at 4, and so we're going to use a parentheses there at 4 since it's an open circle. Okay, this sets a parentheses on either side. That means that this is an open interval. Both ends are non-inclusive. Okay, then for the range, that's going to be bottom to top. And so I start at my lowest y value, which is an open circle here at -1. So I use a parentheses. Then I go up, and my highest y value is up here at 3. That's also an open circle, and so I use a parentheses. So this is an open interval for the domain, an open interval for the range. It's a linear segment, and so it does pass the vertical line test, which means that yes, it is a function. Okay, so I'd like you to pause the video one more time and give these 2 problems a try on your own scrap paper. Find the domain, the range, and determine if each is a function or a relation only. And just be careful, really think about these 2, because these are 2 that have very common mistakes that students find. Okay, so pause the video, come back when you're ready to check. Okay, so we're back, and we'll go over these answers together. The domain in example A is open at -3, closed at +3, and so this is a half open interval. And this open circle at -3, when we look at the range, is always something that confuses students, because when you look at +3, it's a closed circle, but both of those are occurring as the highest value on this graph for the y values. And sometimes it helps students if they write out the ordered pairs at this point. So here at the open circle, this is the point -3, 0. At the closed circle, that's +3, 0. And then at our lower bound, we have 0, -3. Okay, and when you look for the range, we look bottom to top for y values that can be included in the solution. So can -3, our lower bound, be in this solution? Can it be a y value? And the answer is yes, because it's a closed circle. Then we look up, 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 up. If we look this way, here's a 0 for the y value, right? 0 at this point isn't included as a solution. However, if I go this other direction, the 0 is included because that's a closed circle. And since 0 can be a y value, that means this is going to be a closed interval for the range. So our interval is -3 to 0, and it's closed on both sides, so it's a closed interval. Okay, this semicircle passes the vertical line test, and so it is a function. Okay, when we look at example B, and the domain, it is down here at the point -1, -5. And then my highest x value is occurring here at this open circle at 3, 3. Domain is the x values, and so I'm starting at -1 with a bracket. It's continuous all the way through until its highest x value, which occurs at +3, and so that will be half bounded, or sorry, half open, fully bounded, but half open because of this open circle at 3. Okay, now the range, the common mistake that students will make here is they've written down these endpoints, and so they just jump to the conclusion that the lowest bound is -5 inclusive, and then they look up at this other endpoint and say, oh, it goes all the way up to 3. But it doesn't just go up to 3. If you follow this curve all the way up, right, -5 is the lower bound, but we keep going up, up, up. We go higher than 3 on the y-axis. This curve goes all the way up to a maximum here at 2, 4. 2, 4 is my highest y value. So the range of this is going to be a closed interval between -5 and 4, right? This temptation to use the endpoint that you used for the domain, you need to avoid that because the range is your y values, which may not be the same as the endpoint if the graph goes higher before curving and coming back down again. Okay, and this is a segment of a parabola, and so it passes the vertical line test, and that is a yes, it is a function.